Hello students, today in this video we will discuss our NCERT questions from the chapter Chemical Reactions and Equations. So let's see what is the first question. So why should a magnesium ribbon be cleaned before burning in air? So this is the first question. Now when we keep the magnesium for a long period of time, we know in our surrounding oxygen is present. So this oxygen reacts with the magnesium and forms a layer of magnesium oxide. So generally what happens, in our atmosphere oxygen is present. This oxygen reacts with the magnesium and they form magnesium oxide. And this layer of magnesium oxide, it restricts the burning of magnesium ribbon. So to prevent this restriction, we have to clean this magnesium ribbon before burning. So when magnesium is kept for a long period of time, it gets covered with a layer of magnesium oxide, and this layer hinders or restricts the burning of magnesium. Hence it has to be cleaned before burning. So why the magnesium ribbon has to be cleaned before burning? So when magnesium is kept outside for a long period of time, it gets covered with a layer of magnesium oxide, and this layer restricts the burning of magnesium. Hence it has to be cleaned before burning. Okay, let's see the question number 2. So what is asked in the question number 2? Write the balanced equation for the following chemical reactions. So these are the chemical reactions is given. So we have to balance this chemical reaction. Now this kind of chemical reactions, these are called word equation, or it is also called the skeletal equations. So first we have to convert this skeletal equation into chemical equations. Chemical equation means what? The symbolic representation of the reactants and the products. It is called chemical equation. So first we have to convert into chemical equation, then we have to balance the chemical equation. So first equation is what? Hydrogen reacts with chlorine. The symbol of hydrogen is H2. Reacts with chlorine, Cl2. They form hydrogen chloride. Now here you see this reaction is in the unbalanced state. Why? Because the number of atoms in the left hand side and the number of atoms in the right hand side are not equal. Here hydrogen 2, here hydrogen 1. Here chlorine 2, here chlorine 1. Now to balance the chemical equation, already I have uploaded the trick to balance the chemical equations. So if you have not watched that video, you please go through this video, then you will get the clear cut idea how to balance the chemical equations. So now what was the trick I told? First, always whenever we are balancing the chemical equation, first try to balance the metals, then try to balance the non-metals, then oxygen, and at last try to balance the hydrogen. This is the trick. Now here you see, here metals are not given, metals are not there, hydrogen also non-metal, chlorine also non-metal. Then try to balance the non-metal other than oxygen and hydrogen. So here chlorine is how many? Chlorine is the non-metal. So chlorine how many? 2. Here chlorine how many? 1. So put 2 here. Now check. Metals are not there. Chlorine 2, chlorine 2. Hydrogen 2, hydrogen 2. Now this reaction became balanced. Now second question. Barium chloride. Barium chloride formula is BaCl2. Barium reacts with aluminium sulfate. Aluminium sulfate formula is Al2SO4 3. So barium chloride reacts with aluminium sulfate, form barium sulfate. Barium sulfate formula is BaSO4 plus aluminium chloride. Aluminium chloride formula is AlCl3. Now this trick remember. First try to balance the metal. So here in this reaction, what are the metals? Aluminium is the metal, barium is the metal. So always first try to balance the metals. So here left hand side barium is 1, right hand side barium also 1. That means barium is balanced. Now aluminium. This side aluminium also metal. So aluminium 2, this side aluminium is how many? 1. So put 2 here. Now again, whenever we are putting the number to balance the chemical equation, after putting the number always starts from the beginning. Metals. Again check. Barium 1, barium 1. Aluminium 2, aluminium 2. Now try to balance the non-metal. That too other than oxygen and hydrogen. Always oxygen at the second last, hydrogen at last. Non-metals. So find what are the non-metals. Here chlorine is the non-metal and sulfur is the non-metal. So here chlorine is how many? 3 to the 6. 6 chlorine are present. This side how many? Chlorine 2. So here you put 3. Now you see 3 to the 6. 3 to the 6. So chlorine 6. Now again start from the beginning. First try to balance the metal. Aluminium 2, aluminium 2 balanced. Now you see this side became barium 3, but this time barium is 1. So here put 3. Now check. Barium 3, barium 3. Aluminium 2, aluminium 2. Now non-metal. After metal, next is the non-metal. Chlorine here, 3 to the 6. This side chlorine 6, 3 to the 6. This side chlorine also 6. Now look at the sulfur. Here sulfur how many? 3. Here sulfur how many? 3. Sulfur also balanced. Now oxygen. 3 4 are 12. So these 3 will be multiplied with this 4. 3 4 are 12. Oxygen 12. Here oxygen 3 4 are 12. Now this reaction became balanced. So in this way, this trick always remember. Then easily we can, instead of applying the heat and trial method, this trick we can apply to balance the chemical equations. Now the third one, sodium. Sodium symbol is Na plus water. So sodium reacts with the water. It will form sodium hydroxide. Along with the sodium hydroxide, it will form hydrogen gas. Now check whether the reaction is balanced or not. First metal, sodium 1, sodium 1. Now oxygen, oxygen 1, oxygen 1. Here hydrogen how many? Here hydrogen 2, but here hydrogen how many? 3. So hydrogen is in the unbalanced state. So try to balance the hydrogen. This side 2, this side hydrogen how many? 3. So here you put 2. Okay, now again start from the beginning. Sodium 1, sodium 1. Now you see non-metals are not there. Okay, non-metals other than oxygen, hydrogen, and hydrogen are not there. So oxygen try to balance at the second last. So here oxygen how many? 2. Here oxygen how many? 1. So put 2 here. So I told no, whenever we are putting the numbers, always start from the beginning. So here metals, first check the metals. Sodium 1, here sodium 2. So here you put 2. Now you see sodium 2, sodium 2. Oxygen how many here? Oxygen 2. Now hydrogen count 2 to the 4. Here 2 hydrogen, 2 hydrogen. That means the reaction now became balanced. So in this way, this trick remember MNOH, metals, non-metals, oxygen, hydrogens. So by applying this trick, we can balance any type of chemical equations. Okay, now let's see the question number 3. Write a balanced chemical equation with state symbols for the following reactions. Means here in this equation, whatever the compound or the molecule is given, in which state is given, we have to write. Either in solid state, liquid state or aqueous state, we have to write, and then we have to balance the chemical equation. So first what is written? Solutions of barium chloride and sodium sulfate in water. That means this barium chloride is dissolved in water, as well as this sodium chloride also dissolved in water. So barium chloride, BaCl2 in AQ means aqueous medium, dissolved in water. The solution of this barium chloride in water plus sodium sulfate. It is also in aqueous medium. So barium chloride, solution of barium chloride in water plus solution of sodium sulfate in water. They reacted together and they formed what? Insoluble barium sulfate, BaSO4. Sodium sulfate formula will be Na2SO4 because say sodium valency is 1 and sulfate valency is 2. So if we crisscross, the formula of the sodium sulfate will be Na2SO4. Whereas barium sulfate is BaSO4. Why? Barium valency is 2, sulfate valency 2. So we can simplify this one. So the formula will be BaSO4. So that is why sodium sulfate is Na2SO4 whereas barium sulfate is BaSO4. So this solution of the barium chloride and the solution of the sodium sulfate, they reacted and they formed what? Insoluble barium sulfate. Insoluble means what? This one we will get in the solid state, insoluble form, precipitate we will get. Along with this precipitate, what will be formed? Solutions of sodium chloride. Means NaCl we will get in aqueous form. Now we have to balance the chemical equation. Now check. Already a trick I told. First metal, then non-metal, then oxygen, and then hydrogen. So metal, barium is the metal and the sodium is the metal. Here barium how many? 1. Here barium how many? 1. That means barium is balanced. Now sodium. Sodium how many here? 2. Here how many? 1. So here put 2. Now again start from the beginning. Barium 1, barium 1. Sodium 2, sodium 2. Now try to balance the non-metal. That too other than oxygen and hydrogen. So chlorine is the non-metal and the sulfur is the non-metal. Here chlorine how many? 2. So here chlorine how many? 2. So chlorine also balanced. Now check the sulfur. Here sulfur how many? 1. Here sulfur how many? 1. Here oxygen how many? 4. Here oxygen how many? 4. That means it is balanced. So in this way, if we apply the trick, easily we can balance the chemical equations. Now let's see the question number 2. Sodium hydroxide solution in water. That means NaOH in aqueous medium. Means NaOH is dissolved in water. AQ means aqueous solution. Reacts with what? Hydrochloric acid in water. That means HCl in water. They reacted and they formed what? Sodium chloride solution. NaCl in aqueous medium plus water. So water we will get in which state? Water we will get in the liquid state. Now balance this chemical equation. Sodium 1, sodium 1. Sodium is the metal. Sodium balanced. Now try to balance the non-metal other than oxygen and hydrogen. Here chlorine 1, here chlorine 1. Chlorine also balanced. Now try to balance the oxygen. Here oxygen 1, here oxygen 1. Now hydrogen. Here hydrogen 1 plus 1, 2. Here hydrogen is 2. That means the reaction is already in the balanced state. So in this way, if we apply this trick, easily we can balance the chemical equation. Okay, now let's see the next question. A solution of a substance X is used for whitewashing. Name the substance X and write its formula. So a substance is there which is used for whitewashing. First we have to name what was the name of the substance X and what is its formula. Then according to the second question, if this X reacts with the water, what will be formed? We have to write the reaction between the substance X and the water. Now, the substance which is used for whitewashing, it is called the quick lye, or it is also called the calcium oxide. The first question, the substance X is quick lye, or it is called calcium oxide. Its formula is CaO. Okay, so the substance X is the quicklime or calcium oxide. Its formula is calcium oxide. Now, according this question number 2, if this calcium oxide reacts with the water, what they will form? So, calcium oxide reacts with the water. Calcium oxide is called quicklime. So, calcium oxide reacts with the water. It will form calcium hydroxide. And calcium hydroxide, it is called slaked lime. And this process is called slaking of lime. Okay, now let's see the next question. Why does the color of copper sulfate solution change when an iron nail is dipped into it? Now, let's take one beaker. And into this beaker, take some copper sulfate solution, CuSO4 solution. And the color of the copper sulfate solution, it is blue in color. Now, into this beaker, if we dip some iron nail or any iron objects, then this iron is more reactive than the copper. In the reactivity series, iron is placed above the copper. So iron being more reactive, it will displace the copper and they will form the ferrous sulfate or the iron sulfate. And because of this formation of the ferrous sulfate or the iron sulfate, the color of the copper sulfate changes from blue to green. So why the color of the copper sulfate solution changes? Because of the displacement reaction. Iron being more reactive easily can displace the copper and can form the ferrous sulfate, and because due to the formation of the ferrous sulfate, the color changes from blue to green. So when an iron nail is dipped into the solution of copper sulfate, comma, the displacement reaction takes place. Iron being more reactive can displace copper and forms ferrous sulfate or iron sulfate. Due to the formation of iron sulfate, the color of copper sulfate solution changes. Due to the formation of iron sulfate, the color of copper sulfate solution changes from blue to green. And the reaction involved here is copper sulfate reacts with iron, they will form iron sulfate plus copper. Copper sulfate is blue in color and the iron sulfate or the ferrous sulfate is green in color. So due to the formation of the ferrous sulfate or the iron sulfate, the color changes from blue to green. Okay, now let's see the next question. Give an example of a double displacement reaction other than the one which is given in activity 1.10. So in the activity 1.10, one of the example of the double displacement reaction given, that is the sodium sulfate when reacts with the barium chloride, they will form the barium sulfate PPT and along with this sodium chloride. So other than that one, we have to write one more example of the double displacement reaction. So what we can write, for example, potassium hydroxide reacts with sodium chloride. Now, according to the definition of the double displacement reaction, we know that the ions of the two reactants, for here ion is OH negative ion, here this one is chlorine negative ion. So this OH will go in place of chlorine and the chlorine will come in place of OH. So they will form what? Potassium chloride plus sodium hydroxide. So when the potassium hydroxide reacts with NaCl, they form potassium chloride plus sodium hydroxide. So this is an example of the double displacement reaction. Here the ions switches their places and they form the two new products. Okay, now let's see the next question. Identify the substances that are oxidized and the substances that are reduced in the following reactions. Now here two reactions are given and this question is based on the oxidation and the reduction reactions. So we have to find out the substances which is getting oxidized and the substances which is getting reduced. So already know the definition of the oxidation and the reduction. The addition of oxygen to a substance is called oxidation and the removal of oxygen from a substance is called reduction. Now easily from this reaction easily we can say, see the sodium got the oxygen. That means the sodium got oxidized and this oxygen got reduced. So oxygen by losing one electron it got reduced. So the sodium is getting oxidized and the oxygen is getting reduced. So in this reaction the copper oxide it lost one electron and it became copper. That means the copper oxide is getting reduced and the hydrogen by getting one oxygen it got oxidized. So in this reaction substance oxidized is what? Sodium and the substance reduced is what? Oxygen. So here according to this question substance oxidized is hydrogen and the substance reduced is copper oxide. So the losing of electron is called reduction and the gaining of oxygen is called oxidation. So in this way easily we can find out what are the substances is getting oxidized and what are the substances getting reduced. So the first question is which of the following statements about the reaction below are incorrect? We have to find out the incorrect statement or the incorrect option. So this is the reaction is given. Lead oxide reacts with the carbon, they form the lead and the carbon dioxide. So the first option is given, lead is getting reduced. So this is the example of the oxidation and the reduction reaction. So we have to find out what are the substances getting reduced and what are the substances getting oxidized. And we have to find out the incorrect statement. First, what is the first option is given? Lead is getting reduced. So if you look at the reaction carefully, here the lead is not getting reduced. Here the lead oxide is getting reduced. See, lead oxide, PbO. So the oxygen, this lead oxide lost one electron and it became lead. So this option is incorrect option. Lead is not getting reduced. Lead oxide is getting reduced. Next option is carbon dioxide is getting oxidized. Here you see the carbon dioxide is not getting oxidized. The carbon is getting oxidized. Carbon by gaining one electron, it became carbon dioxide. So carbon dioxide is not getting oxidized. This is also incorrect option. Now the third option, carbon is getting oxidized. It is correct. Carbon by gaining one electron, it became carbon dioxide. This is the correct option. lead oxide is getting reduced. So just now I told no, the lead oxide is getting reduced. The lead oxide, from this lead oxide, by losing this oxygen, lead oxide became lead. So this option also correct option. So according to this question, we have to find out the incorrect statement. So which are the incorrect statements? So options are given A and B, A, C, A, B, C and all. So which option will be correct? The option 1. So this statement A and the statement B are the false statement or the incorrect statement. Okay, now let's see the question number 2. So iron oxide reacts with aluminium. They form aluminium oxide and the iron. So the above reaction is an example of a combination reaction, double displacement reaction, decomposition reaction and the displacement reaction. So here clearly we can see the iron oxide reacts with aluminium. Now aluminium is more reactive. In the reactivity series, aluminium is placed above the iron. So aluminium is more reactive than the iron. So aluminium easily can displace this iron and they formed what? Aluminium oxide plus iron. Since in this reaction the aluminium replaces the iron, so that is why it is an example of the displacement reaction. So see, if you look at the reactivity series also, potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead, hydrogen, copper, mercury, silver, gold, platinum. So see, in this reactivity series, the aluminium is placed above the iron. So iron is more reactive than the iron. So that is why iron easily could displace this. This aluminium easily could displace this iron. So that is why it is an example of the displacement reaction. Now let's see the third question. What happens when dilute hydrochloric acid is added to iron fillings? So hydrochloric acid formula is HCl. When the hydrochloric acid reacts with the iron, then what they will form? So see, in the reactivity series, iron is placed above the hydrogen. So iron easily can displace this hydrogen and they will form FeCl2, that is iron chloride. Along with the formation of the iron chloride, there will be formation of hydrogen gas. So when the dilute hydrochloric acid reacts with the iron fillings, they form iron chloride and hydrogen gas. So which option will be correct option? That is the option A. Hydrogen gas and the iron chloride are produced. Okay, now let's see the question number 4. What is a balanced chemical equation? Why should chemical reactions be balanced? Okay, for example, if I write a equation, magnesium plus oxygen, they form magnesium oxide. Now, if you look at the equation, this is called reactants. The left hand sides are called reactants and the right hand side is called the product. So balanced chemical equation means that the number of atoms in the reactant side should be equal to the number of atoms in the product side. But if you look at this equation, here you see in the reactant side, how many atoms of magnesium is present? 1. Here how many? 1. So magnesium is balanced. Oxygen here how many? 2. Here oxygen how many? 1. So oxygen is in the unbalanced state. So this kind of chemical equation, it is called the unbalanced chemical equation or it is also called skeletal equation. So what is balanced chemical equation? So balanced chemical equation means the number of atoms in the reactant side should be equal to the number of atoms in the product side. Then the reaction is said to be, or then the equation is said to be balanced. Now the next part of the question, why should we balance the chemical equations? So from the law of conservation of mass, we know that mass can neither be created nor be destroyed in a chemical reaction. For example, in this reaction, if I take 2 gram of magnesium and if it is reacted with the 5 gram of oxygen. Then I will get the product magnesium oxide, and the mass of the magnesium oxide will be 7 gram. So in a chemical reaction, mass can neither be created nor be destroyed. Mass of the reactants always will be equal to the mass of the product. So to satisfy the law of conservation of the mass, a reaction should be balanced. So what do you mean by balanced chemical equation? Answer is, if the number of atoms in the reactant side is equal to the number of atoms in the product side, then the equation is said to be balanced. Now the next part is, why should chemical reactions be balanced? So chemical reactions should be balanced to satisfy the law of conservation of mass. So to satisfy the law of conservation of mass, a chemical equation has to be balanced. So what is a balanced chemical equation? If the number of atoms in the reactant side is equal to the number of atoms in the product side, then a chemical equation is said to be balanced. Why should we balance the chemical equations? To satisfy the law of conservation of mass. Okay, now let's see the question number 5. Translate the following statements into chemical equations and then balance them. So here, according to this question, some chemical reactions are given in the statement form. First, we have to convert into the chemical equation. Chemical equation means what? This statement we have to write in their symbolic form. So after writing in the chemical equations or after writing in the symbolic form, we have to balance them. So what is the first question? Hydrogen gas combines with nitrogen to form ammonia. So hydrogen symbol is H2. Hydrogen combines with nitrogen N2 and they form what? Ammonia. Now this reaction is called the skeletal equation because it is in the unbalanced state. Here you will see in the reactant side hydrogen is 2, but in the product side hydrogen is 3. In the reactant side nitrogen is 2, but in the product side nitrogen is 1. Now to balance the chemical equation, don't use the heat and trial method. So always this trick remember. Whenever you are going to balance the chemical equation, first try to balance the metal, then try to balance the non-metals, then oxygen, and then hydrogen. This trick always remember. Don't use the heat and trial method. Though oxygen and the hydrogen also non-metal, but oxygen and the hydrogen try to balance at last. Oxygen second last and the hydrogen at last. Always try to balance the hydrogen at last. Now look at this reaction. Here metals are absent. So metal no need to balance. Then non-metal other than oxygen and hydrogen. So which one is the non-metal? Nitrogen is the non-metal. Here nitrogen how many is present? 2. Here nitrogen is how many? 1. So this side hydrogen is less. So put 2 here. Now again start from the beginning. Metals are not there, non-metals. Nitrogen 2, nitrogen 2. Now oxygens are absent. Now try to balance the hydrogen. This side hydrogen how many? 2. This side hydrogen how many? 3 2 are 6. These 3 and 2 will be multiplied. Here the hydrogen will be 6. This side how many? 2. So put 3. Now you check. Now you count the number of atoms in the left hand side and the right hand side. So hydrogen this side 6. This side hydrogen 6. Balanced. Nitrogen this side 2. This side 2. So the reaction became balanced. Now the next question. Hydrogen sulfide gas. Hydrogen sulfide formula H2S. Hydrogen sulfide burns in air. Burns in air means what? It reacts with the oxygen to give water H2O plus sulfur dioxide SO2. Now you check the reaction is in the balanced or unbalanced state. Hydrogen 2, hydrogen here 2. Sulfur 1, sulfur 1. Oxygen here 2. This side oxygen 1 plus 2, 3. That means the reaction it is a skeletal equation. So this skeletal equation we have to convert into the balanced chemical equation. So three always remember, first metals, non-metals, oxygen and the hydrogen. So in this reaction also metals are absent. Then non-metal other than oxygen and the hydrogen. So which one is the non-metal? Sulfur is the non-metal. But here sulfur in the left hand side 1, here also right hand side 1. Then try to balance the oxygen. So here you see oxygen 2, here oxygen 1, 3. Here oxygen how many? 2. So this side oxygen is less. Left hand side oxygen is less. So put 2 here. Now check. Metals are absent, non-metals only sulfur. This side sulfur 1, sulfur 1. Now you see oxygen this side became 4. This side became oxygen 3. Now this side oxygen became less. So try to balance right hand side. So put 2 here. Now after putting the number always start from the beginning. Metals are absent. Sulfur now check. Sulfur this side 1, this side 1. Sulfur balanced. Now oxygen 2 to the 4. Here 2 oxygen plus 2 oxygen 4. Now count the hydrogen. So here hydrogen how many? 2. Here hydrogen how many? 4. Now the hydrogen became unbalanced. So this side hydrogen is more. This side hydrogen is 4. This side hydrogen is 2. So now try to balance the hydrogen. So put 2 here. Now again start from the beginning. Metals are absent. So whenever you are putting the number, always start from the beginning. Check, start from the metals. So here metals are absent. Then if metals are absent, then non-metals. Now check the non-metals. See, this side sulfur 2, this side sulfur is 1. So put 2 here. Okay, now again start from the beginning. Metals are absent. Sulfur 2, sulfur 2. Now count the number of oxygen. Here you see 2 to the 4 oxygen because these two will be multiplied. So 4 oxygen plus 2 oxygen. So right hand side 6 oxygens are present. Left hand side how many? 4. So this side oxygen is less. So write 3 here. Now you see left hand side oxygen became 6. Now check the hydrogen. Hydrogen 2 to the 4. This side hydrogen 2 to the 4. Now the reaction became balanced. So instead of applying the heat and trial method, always follow this track. Metal, non-metal, oxygen and hydrogen. Okay, now let's see the question number C. Barium chloride reacts with aluminum sulfate to give aluminum chloride and a precipitate of barium sulfate. Now, barium chloride formula is BaCl2. Barium chloride reacts with aluminum sulfate. Aluminum sulfate formula is Al2SO4 3. So why the aluminum sulfate formula is Al2SO4 3? See, aluminum symbol is Al and the sulfate is SO4. The valency of aluminum is 3 and the sulfate is 2. Now crisscross. So the chemical formula of aluminum sulfate will be this valency of this will go with aluminum and the valency of this aluminum will go with sulfate. So that is why the formula of aluminum sulfate is Al2SO4 3. So barium chloride reacts with aluminum sulfate to give aluminum chloride. Aluminum chloride formula is AlCl3. Along with the formation of the aluminum chloride, they will form a precipitate of barium sulfate. Barium sulfate formula is BaSO4 and they will form one precipitate. So this arrow means what? This is an insoluble solid or precipitate. Now it is a skeletal equation. We have to balance this equation. So just now I told no trick. Always try to first balance the metal, then non-metal, then oxygen, and at last try to balance the hydrogen. First identify which are metals. So see, barium is the metal, aluminium is the metal. Now check. Barium left hand side 1, right hand side 1. Barium is balanced. Now check the aluminium. Aluminium 2, here aluminium 1. So aluminium is less. So this side put 2. Now see, metal became balanced. Barium 1, barium 1. Aluminium 2, aluminium 2. So the aluminium also became balanced. Now after the metal, next is non-metal. So identify the non-metal other than oxygen and hydrogen. So here chlorine is the non-metal, sulfur is the non-metal. So chlorine this side how many? 2. This side chlorine how many? 3 2 are 6. This side chlorine is more. So try to balance this side. So put 3 here. So this will become 3 2 are 6. So whenever you are putting the number, always start from the beginning, that is from the metals. Again check, start from the metals. This side barium is 3. This side barium is how many? 1. So put 3 here. Now check the aluminium. This side aluminium is 2. This side aluminium is 2. So metals are balanced. Now check the non-metals. So chlorine this side 3 2 are 6. 3 2 are 6. Now check the sulfur. Here sulfur how many? 3. This 3 is common for both sulfur and the oxygen. Sulfur is 3. Here sulfur how many? 3. Now check the oxygen. 3 4 this 3 will be multiplied with the 4. 3 4 are 12. Oxygen left hand side how many? 12. Check right hand side. 3 4 are 12. So oxygen also balanced. So in this way, instead of applying the heat and trial method, apply this trick. MnOH. Metals, non-metals, oxygen, and then hydrogen. Next you see, potassium metals reacts with water. So potassium formula is K. Potassium reacts with water to give potassium hydroxide, KOH, and hydrogen gas. Now you balance, this is a skeletal chemical equation, balance the equation. So this side potassium, first metal, potassium 1, potassium 1. Then non-metal other than oxygen, hydrogen. So non-metals other than oxygen and the hydrogen are not there. Now try to balance the oxygen. Oxygen here how many? Oxygen 1, oxygen 1. Then at last always try to balance the hydrogen. So this side hydrogen how many? 2. This side hydrogen how many? 2 plus 1, 3. So this side hydrogens are more. So the side where the number of atoms are less, that side first try to balance. So hydrogen 2, so put 2 here. So whenever we put the number, always we start from the beginning, from metals. Metal 1 means potassium 1, this side potassium 1. Then non-metal. So non-metals other than oxygen and hydrogen are not there. Then oxygen. This side oxygen 2, this side oxygen how many? 1. So this side oxygens are less. So put 2 here. Now again start from the beginning. Check from the metals. This side metal 1. This side metal became now how many? 2. So put 2 here. So potassium 2, potassium 2. Now check oxygen. This side oxygen 2, this side oxygen 2. Now count the hydrogen. 2 2 are 4. Here 2 hydrogen. 2 hydrogen plus 2 hydrogen, 4 hydrogen. Now the reaction became balanced. So in this way we can balance any type of chemical equation. Okay. Now let's see the question number 7. So this question number 7 also related to balancing the chemical equations. So here word equations is given. First we have to convert into chemical equations, then we have to balance. Now here the compound name is given. First we should know how to convert this compound name into the chemical formula. So calcium hydroxide. Formula of calcium hydroxide is CaOH2. Calcium hydroxide reacts with carbon dioxide, CO2. They form calcium carbonate. Calcium carbonate formula is CaCO3 plus water. So first you have to convert the word equation into chemical equation, then you have to balance. Now try to balance. So first try to balance the metal. So identify the metal. So calcium is the metal. So calcium left hand side 1, right hand side also calcium 1. Now try to balance the non-metal other than oxygen and hydrogen. So see, which one is the non-metal? Carbon is the non-metal. So carbon this side 1, this side also carbon 1. Now try to balance the oxygen. Now check the oxygen. This side oxygen how many? 2 plus 2, 4. Here 3 plus 1, 4. So oxygen also in the balanced state. Now check the hydrogen. So hydrogen here left hand side 2, right hand side also hydrogen 2. That means the reaction is already in the balanced state. Now the next reaction. Zinc reacts with silver nitrate. Zinc reacts with silver nitrate. Silver nitrate formula AgNO3. It will form zinc nitrate. Zinc nitrate formula ZnNO3 2. So zinc reacts with the silver nitrate. They will form zinc nitrate plus silver. Now try to balance. First try to balance the metal. So see, left hand side zinc 1, right hand side also zinc 1. Left hand side silver 1, right hand side also silver 1. Now try to balance the non-metal. So see, nitrogen is the non-metal. So left hand side nitrogen 1, right hand side nitrogen is 2. So left hand side number of nitrogens are less. So this side 2, this side 1. So put 2 here. Now whenever we are putting the number, always start from the beginning, from the metal. Now check again from the metal. Zinc 1, zinc 1. Silver 2, this side silver 1. So put 2 here. So zinc 1, silver 2, silver 2. Now non-metal. Nitrogen 2, this side nitrogen 2. Now oxygen. So oxygen 3 to the 6. Here oxygen 3 to the 6. So the now reaction became balanced. Now question number C. Aluminium reacts with copper chloride. They form aluminium chloride plus copper. Now aluminium Al plus copper chloride. Copper chloride is CuCl2. They form aluminium chloride. Aluminium chloride formula is AlCl3 plus copper. Now try to balance. Here you see, aluminium is the metal, copper is the metal. So aluminium left hand side 1, right hand side 1, balanced. Copper right hand side 1, sorry, left hand side 1, right hand side also 1. Then non-metal chlorine. So this side chlorine is 2, this side chlorine is 3. Now first try to balance the chlorine. So how can you balance? So chlorine this side is 2. This side number of chlorines are less. This side number of chlorines are more. So if I put here 2 to the 4 will be. So here if I put 3 to the will be 6. So if I put 3 here. Okay. Now check. And 2 here. Now the chlorine will become balanced. 3 to the 6. Here 3 to the 6. Chlorine will become balanced. Again check from the beginning. Aluminium 1. Now this side aluminium became 2. So put 2 here. So aluminium 2, aluminium 2. Now check the copper. This side copper 3, this side copper is 1. So put 3 here. Now the metals became balanced. The non-metal chlorine 3 to the 6, 3 to the 6. So now the reaction became balanced. Now the last equation. Barium chloride reacts with potassium sulfate. So barium chloride formula is BaCl2. So barium chloride reacts with potassium sulfate. Potassium sulfate formula is K2SO4. They will form barium sulfate, BaSO4, barium sulfate. Along with the formation of the barium sulfate, they will form potassium chloride, KCl. Now try to balance. First try to balance the metal. So see, barium is the metal, potassium is the metal. Barium left hand side 1, right hand side also 1. Potassium left hand side 2, right hand side 1. So right hand side number of potassiums are less. So put 2 here. Now again start from the beginning. Barium 1, barium 1. Potassium 2, potassium 2. Now try to balance the non-metal other than oxygen and hydrogen. Chlorine is the non-metal, sulfur is the non-metal. So left hand side chlorine 2, right hand side also chlorine 2. Chlorine also balanced. Sulfur. Left hand side sulfur 1, right hand side also sulfur 1, balanced. Now oxygen. Left hand side oxygen 4, right hand side also oxygen 4. So that is the reaction became balanced. Okay, now let's see the question number 8. So write the balanced chemical equation for the following and identify the type of reaction in each case. So first we have to balance this chemical equation and then we have to tell what type of this chemical equation. So the first equation is potassium bromide. Potassium bromide, KBr, in aqueous form. So in this equation that state also given. That means this potassium bromide, this is the solution of potassium bromide in water. AQ means aqueous solution. Plus barium iodide. Barium iodide formula is BaI2. It is also aqueous solution. They formed potassium iodide, Ki. It is also aqueous solution. Plus barium bromide. It is in solid form. So first we have to convert into balanced state. Then we have to tell it is a kind of what kind of chemical reaction. So see, potassium bromide reacts with barium iodide, form the potassium iodide plus barium bromide. Now first try to balance the metal. So this side potassium 1, potassium 1, barium 1, barium 1. Now try to balance the non-metal. So what are the non-metal? Bromine is the non-metal, iodine is the non-metal. So see, this side bromine how many? 1. This side bromine how many? 2. So this side number of bromines are less. So put 2 here. Now again start from the beginning. First try to balance the metal. Potassium 2, this side potassium is 1. So put 2 here. Now potassium 2, potassium 2. Barium 1, barium 1. Now bromine, this side bromine 2, this side bromine 2. Then iodine, iodine 2, this side iodine 2. Now the reaction became balanced. Now we have to tell it is a kind of what kind of reaction. So clearly we can see, here you see, this ion took the place of bromine and bromine took the place of iodine. So it is an example of double displacement reaction. So what kind of reaction? It is a type of double displacement reaction. It is also the example of the precipitation reaction, because here we will get the barium bromide which is in the solid form, which will be get in the form of precipitate. So it is an example of double displacement reaction as well as precipitation reaction. Next is zinc carbonate. Zinc carbonate formula is ZnCO3. Its state is given in S means solid state. So zinc carbonate breaks into zinc oxide. It is also in the solid form, plus carbon dioxide in the gaseous form. So let's first balance this chemical equation. So first try to balance the zinc. Zinc is the metal. Zinc left hand side 1, right hand side also 1. Zinc is balanced. Then carbon. Carbon is 1, this side also carbon 1 balanced. Now oxygen. This side oxygen is 3, this side 1 plus 2 is 3. That means the reaction is already in balanced state. Now we have to tell it is a kind of what kind of reaction. So clearly here we can see here reactant is 1. The reactant is broken down into 2 products. So if a single reactant breaks into 2 or more products, so it is a kind of what kind of reaction? It is a kind of decomposition reaction. So it is a type of decomposition reaction. Okay, now let's see the question number C. Hydrogen reacts with chlorine, they form hydrogen chloride. So this hydrogen is given in gaseous state, plus fluorine, Cl2. It is also in gaseous state. They form hydrogen chloride. Hydrogen chloride formula is HCl. It is also in gaseous state. So now first try to balance this chemical equation. So here metals are not there. Then try to balance the non-metal. So chlorine is the non-metal. So this side chlorine is 2. This side chlorine how many? 1. So here put 2. Now check. Metals are not there. Then chlorine 2 balanced. Now this side hydrogen 2, this side hydrogen 2. Now the reaction became balanced. Then we have to tell It is an example of what kind of chemical reaction? So here clearly we can see that two reactants they combined together and they formed a single new product. So it is an example of combination reaction. So it is an example of combination reaction. Now the question number D. So magnesium is given in solid state. Magnesium reacts with hydrogen chloride HCl. It is given in aqueous. Aqueous means aqueous solution of hydrogen chloride. They formed magnesium chloride. Magnesium chloride formula is MgCl2 plus hydrogen gas. So first we have to balance this chemical equation. So first try to balance the metal. So which one is the metal? Magnesium is the metal. So number of magnesium in the left hand side also 1, right hand side also 1. Now try to balance the non-metal other than oxygen and hydrogen. So which one is the non-metal? Chlorine is the non-metal. So left hand side chlorine is 1, right hand side chlorine is 2. So put 2 here. Now again start from the beginning. Magnesium 1, magnesium 1. Now non-metal. Chlorine 2, chlorine 2. Now oxygen. So oxygens are not there. Now try to balance the hydrogen. So this side hydrogen is 2, this side hydrogen is 2. Now the reaction became balanced. Now we have to tell this is an example of what kind of reaction. So here you can see magnesium displaces this hydrogen. Magnesium took the place of hydrogen and they form the magnesium chloride. So since magnesium displaces the hydrogen, that is why it is an example of the displacement reaction. In the reactivity series also, magnesium is placed above the hydrogen. Magnesium easily can displace the hydrogen. Magnesium is more active element than the hydrogen. It is an example of displacement reaction. Now let's see what is the next question. So what does one mean by exothermic and endothermic reactions? So exothermic reaction, this thermic word it is related to the heat. So in case of exothermic reaction, when the product will be formed, along with the formation of the product, some amount of heat will be released. So let's suppose if I write magnesium reacts with the oxygen. So they will form magnesium oxide, and along with the formation of the magnesium oxide, some amount of heat will be released. This is the symbol of the heat. It's called delta. So exothermic, what is exothermic reaction? So in case of exothermic reaction, the heat will be released along with the formation of the product. And endothermic reaction. Endothermic is just the opposite of the exothermic reaction. Here, to take place the reaction, the reactant need or the reactant will absorb the heat and product will be formed. For example, calcium carbonate. It will absorb the heat and it will convert into calcium oxide plus carbon dioxide. So here you see in case of exothermic reaction, after the formation of the product, along with the formation of the product, heat will be released. And in this case, in case of endothermic reaction, the reactant will absorb the heat and it will convert into the products. So what will be the definition? So first, exothermic reaction. So it is a type of chemical reaction where the formation of product is accompanied by the evolution of heat. So in this type of reaction, the heat will be released along with the formation of the product. So example, magnesium when burns in presence of oxygen, it converts into magnesium oxide and some amount of heat will be released. So it is an example of the exothermic reaction. Now, endothermic reaction. Endothermic reaction. So it is a type of chemical reaction where the formation of product is accompanied by the absorption of heat. Just we have to change the one word. In case of exothermic, after the formation of the product, it will be released. In case of endothermic reaction, the reactant will absorb the heat and it will be converted into the products. Example, calcium carbonate. If you provide the heat to the calcium carbonate, it will convert into calcium oxide plus carbon dioxide. So these two are the definitions of the exothermic and endothermic reactions. Okay. Now the next question is, why is respiration considered an exothermic reaction? Explain. So first we should know what is respiration. So respiration is a biological process which takes place inside our body or inside our cells. So what is respiration? So whenever we take the food ultimately goes inside the cell. Then inside the cell also one specific cell organelle we have, that is the mitochondria. So the food will enter into the mitochondria and oxygen also will enter inside the mitochondria. So this food in presence of oxygen, it will break down into carbon dioxide plus water, and along with this some amount of heat energy will be released. So this process, all this is the reaction of respiration, and this takes place inside the mitochondria. That is why mitochondria also called as the uh, energy house of our cell. So this whole process takes place inside the mitochondria, and when this product forms, along with the formation of the product, some amount of heat is getting released. So that is why this respiration is also called the exothermic reaction. So respiration is considered an exothermic reaction because during respiration food in the presence of oxygen is broken down into carbon dioxide, water and heat energy. So from the definition of the exothermic reaction, we know that the chemical reactions where heat is released along with the formation of the product, it is called exothermic reaction. So in case of respiration also the same thing happens. The heat is getting released along with the formation of the product. That is why the respiration is considered as an exothermic process. So this is the reaction of the respiration, C6H12O6, that is the glucose molecule. So this glucose molecule in presence of oxygen, it is broken down into carbon dioxide plus water plus heat energy. So that is why the respiration is considered as an exothermic reaction. Okay, the next question is, why are decomposition reactions called the opposite of combination reactions. Write equations for these reactions. So, uh, from the definition of the combination reaction, we know that in case of combination reaction, as the name suggests, two or more, in case of combination reaction, two or more reactants they will combine and they will form a single new product. But whereas in case of decomposition reaction, just the opposite of the combination reaction happens. See, in case of decomposition reaction, a single reactant will break and they will form two or more products. So see, this combination and the decomposition, they are just opposite of each other. In case of combination reaction, the reactants are two. But in case of decomposition reaction, the products are two. In combination reaction, the product is 1, but in case of decomposition reaction the reactant is 1. So why they are called opposite of each other? Because in case of combination reaction, two or sometimes more than two reactants they combine and they form a single new product, whereas in case of decomposition reaction a single reactant decomposes into two or more products. So that is why they are called opposite of each other. So decomposition reaction decomposition reactions decomposition reactions are opposite of combination reactions because because in case of combination reactions, two or more reactants combine to form a single new product. So example of the combination reaction is magnesium reacts with oxygen, they form magnesium oxide. Whereas in case of decomposition reaction, in case of decomposition reactions, a single reactant breaks into two or more products. Example, calcium carbonate. If you provide the heat to the calcium carbonate, it will convert into calcium oxide plus carbon dioxide. So that is why decomposition and the combination, they are just opposite of each other. In combination reaction, the two reactants combine and they form a single new product. In case of decomposition reaction, a single reactant breaks into two or more products. Okay, now let's see the question number 12. Write one equation each for decomposition reactions where energy is supplied in the form of heat, light or electricity. Means here we have to write three examples of the decomposition reactions. In one case, the source of energy will be heat. In another case, the source of energy will be light. And in another case, the source of energy will be electricity. So, first one, calcium carbonate. If we provide the heat to the calcium carbonate, it will break into calcium oxide plus carbon dioxide. So it is an example of the decomposition reaction where the source of energy is the heat. Next, the source of energy has to be light. Silver chloride in presence of light, it breaks into silver plus chlorine gas. And the third one, the source of energy has to be electricity. So through the water, if we pass the electricity, it will convert into hydrogen gas plus oxygen gas. So these are the three examples of the decomposition reactions where the source of energy is the different. In one case, the source of energy is the heat, here light, here electricity. So the decomposition reaction where the reactant breaks into the products in presence of heat. So this kind of decomposition reaction is called thermal decomposition. Next, the decomposition reaction where the source of energy is the light. This kind of decomposition it is called photolysis. It is called thermal decomposition. This one is called photolysis. Photo means light and lysis means breakdown. And here the source of energy is the electricity. This type of decomposition reaction it is called electrolysis. Now let's see the next question. That is question number 13. What is the difference between displacement and double displacement reactions? Write equations for these reactions. So we have to write the difference between displacement and the double displacement reactions along with their examples. So we know that displacement, as the name suggests, displacement, here a more active element will displace the less active element. For example, say copper sulfate. If it reacts with the iron, so here iron in the reactivity series, iron is placed above the copper. So iron easily can displace the copper. So it will form the iron sulfate. So this iron displaces the copper and forms the ferrous sulfate or the iron sulfate. So this is an example of the displacement reaction. So what is displacement reaction? So it is a type of chemical reaction where a more active element can displace the less active element from their compound. Whereas in case of double displacement reaction, as the name suggests, double displacement. So in this case, the displacement will take place from two positions. For example, sodium sulfate reacts with barium chloride. They form barium sulfate. Barium sulfate we will get in the form of PPT, precipitate. Along with this, they will form sodium chloride. So in this case, SO4 means sulfate is the ion and the chlorine is the ion. So these ions, they will switch their places. So in this case, the displacement will take place from two positions. So these ions, chlorine ion and the sulfate ion, they will switch their places and they form the two new products. So this is the difference between displacement and double displacement reaction. First one, right? In case of displacement, in case of displacement reaction, a more active element displaces the less active element from their compound. Whereas in case of double displacement reaction, the ions of two reactants switch their places, forming two new products. So in case of displacement reaction, the displacement occurs from one position. In case of double displacement reaction, the displacement takes place from two positions. So in case of displacement reaction, a more active element easily can displace the less active element. Whereas in case of double displacement reaction, the ions of the two reactants, they will switch their places, and as a result we will get the two new products. Now we'll be writing the equations of both the reactions. So first one, example of displacement reaction. So copper sulfate, it reacts with iron. They will form iron sulfate plus copper. Next, example of double displacement reaction. The example is sodium sulfate reacts with barium chloride. They will form barium sulfate plus sodium chloride. So these are the differences between displacement reaction and double displacement reaction, and these two are the equations of these reactions. Okay, now this question number 14 says that in the refining of the silver, the recovery of silver from silver nitrate solution involved displacement by copper metal. Write down the reaction involved. Means uh, in the refining of the silver, so to extract the silver from the silver nitrate solution, we have to react this solution with the copper metal. And as we know, the copper is more reactive than the silver. So from this nitrate solution, copper easily can displace the silver and we can get the pure silver metal. So the reaction involved here is silver nitrate solution. So silver nitrate formula is AgNO3, silver nitrate. The valency of silver also 1, nitrate also 1. So it reacts with the copper. So copper is more reactive than the silver. Copper easily can displace this silver. Then they will form CuNO3 2. So the formula of copper nitrate is like this, because the valency of the copper is 2 plus silver. So this is the reaction involved in the refining of the silver metal. So this one is silver nitrate, this one is copper metal, this one is called copper nitrate, and this one silver metal. So this is the reaction involved in the refining of the silver. Okay, now the question number 15 is that what do you mean by a precipitation reaction? Explain by giving examples. So already we have discussed now in the types of the reactions, in the types of the chemical reactions. So precipitation, in case of precipitation reaction, two soluble reactants they combine together and they form the products. So out of two products, one of the product will be insoluble solid, and this insoluble solid is called the precipitate. And this precipitate, if we observe in a test tube, it will settle down at the bottom of the test tube. So in case of precipitation reaction, always a precipitate or the insoluble product we will be getting. So what is precipitation reaction? It is a type of chemical reaction where two soluble reactants combine and form one of the products as an insoluble solid called a precipitate. Example, say potassium bromide, KBr, aqueous solution of potassium bromide. Aqueous means what? This potassium bromide, it is soluble in water, plus barium iodide, Bai2, barium iodide. It is also soluble in water, aqueous solution of barium iodide. So if they react, here the double displacement reaction will take place. Iodine will come in place of potassium bromine, and the bromine will go in place of iodine. So what they will form? They will form potassium iodide. Potassium iodide also we will get in aqueous form, but we will get the barium bromide. This barium bromide we will get in the form of precipitate. This arrow means we will get in the solid form, that is the precipitate. So this is one of the reaction of the precipitation reaction. Then one more example we can write, sodium sulfate. It is also aqueous solution of sodium sulfate. If it reacts with barium chloride also in aqueous medium, they will form what? They will form barium sulfate, and this barium sulfate we will get in the form of precipitate. Along with this we will get NaCl solution. So these two are the examples of the precipitation reaction. Why these are called precipitation reaction? In both the cases, the one of the products we got insoluble solid. Okay, now let's see the next question. Explain the following in terms of gain or loss of oxygen with two examples each. So we have to define the oxidation and the reduction reactions in terms of their gaining or losing of electrons. We know that this oxidation and the reduction we can define in various ways. Oxidation means the gaining of oxygen is called oxidation, or we can say the removal of hydrogen is called oxidation. In the same way, the losing of oxygen is called reduction and the gaining of hydrogen is called reduction. So we have to define this oxidation and the reduction in terms of their gaining or losing capacity of oxygen. So oxidation, how can we define? The addition of oxygen to a substance is called oxidation. So the gaining of oxygen is called oxidation. Example, hydrogen reacts with the oxygen. They will form H2. Here you see the oxygen gets added to the hydrogen. So this addition of oxygen is called oxidation. Then we can write magnesium reacts with the oxygen. It will form magnesium oxide. It is also example of the oxidation reaction. Now reduction. Reduction is just opposite of oxidation. The losing of oxygen from a substance is called reduction, or we can say the removal of oxygen from a substance is called reduction. Example, copper oxide if it reacts with the hydrogen. Here, this copper oxide will lose the oxygen. So they will form water plus copper. Next, zinc oxide reacts with the carbon. So in this case, zinc oxide will lose the oxygen. So they will form zinc plus carbon monoxide. So these are the definition of the oxidation and the reduction in terms of their gaining and the losing of oxygen. And these two are the examples of the oxidation and reduction. Okay, now let's see the next question. A shiny brown colored element X on heating in air becomes black in color. Name the element X and the black colored compound form. So, since the element X has the shining surface, that means the element X surely will be a metal. Now, so what is the metal which is brown in color? So we know that the coppers are brown in color. So if we burn this copper in presence of air, that is, if we provide the oxygen to the copper, then what will happen? Let's see. Copper, if it burns in presence of oxygen, then we will get to see copper oxide. And this copper oxide, it is black in color. So if we burn any copper metal, we will get to see the surface of the copper metal will be covered by a black substance. This black substance is nothing but the copper oxide. Because of this formation of the copper oxide, the surface gets covered with a black layer. So the shining brown element X is copper. Then name the element X and the black color compound form. Then copper reacts with oxygen and forms a black colored compound, that is copper oxide. So the element X is the copper. If it reacts with the oxygen, it will form copper oxide. And this copper oxide is the black in color. So due to the formation of the copper oxide, we will get to see a black colored compound. Okay, now before solving this question number 18, 19 and the 20, we must know the two concepts, that is corrosion and the rancidity. And these two are the last topic from our chapter, that is chemical reactions and equations. So both these processes, these are the damaging processes. They damage the things. So the corrosion means the damaging of the metal objects, and in case of rancidity, the damaging of the food items which contain the oils and the fats. It is called rancidity. So corrosion means the oxidation of metal objects. Whereas rancidity means what? Rancidity means the oxidation of oils and fats present in food items. So the food items containing the oil and the fat, their oxidation takes place, and when the oxidation of the oil and the fats takes place, it develops a bad taste and a bad smell. For example, uh, during the summer time, if we keep the butter outside, uh, we will see that it will develop a bad taste and a bad smell. So this is called the rancidity, or we can say the butter became rancid. So these are the damaging processes. And in case of corrosion means what? The oxidation of the metal items. So oxidation means what? The addition of the oxygen. So when we keep the metal objects outside, in our atmosphere oxygen is present. Sometimes this metal objects comes in contact with the moisture, that is the water. So it converts into their oxide forms. For instance, when we buy the iron objects, so when the iron objects are new, we see very shining surface of the iron objects. But as the time passes, we see the iron objects gets coated with a layer of brown color. So see, these iron objects, when it comes in contact with the oxygen, it converts into ferrous oxide. And this ferrous oxide forms a layer of brown color, and this layer, it is called the rust. So the rusting of the iron, it is also example of the corrosion. So or we can say the corrosion of the iron specifically is known as rusting. Then the copper objects, it is brown in color. So sometimes we see the copper objects gets coated with a green layer. So this tarnishing of the copper object also example of the corrosion. Or we can see the silver object also gets covered with a layer of black color. It is also example of the corrosion. So this corrosion and the rancidity both are the damaging phenomena. So corrosion, it is specifically meant for the metals, and the rancidity, it is meant for the food items. So why this corrosion and the rancidity takes place? Because of the oxidation. Both the processes takes place because of oxidation. So corrosion means what? Corrosion means the eating away of the metal objects by the action of oxygen or moisture or sometimes with chemicals. And whereas rancidity means what? The oxidation of the oil and the fats which are present in the food items, resulting the change of their smell and the taste. So that is why we see now the chip manufacturers, they flush the packet of the chip with one gas. So this gas is nothing but they keep the food items in a nitrogen gas, and being non-reactive, or the nitrogen is the inert gas. This nitrogen acts as a antioxidant. So it prevents the food items from getting oxidized. So that is why when we buy the chips packets, we get 4 or 5 chips, and most of the packet, it is flushed with air. And because of this air only, we are getting the fresh chips. So corrosion, it is the oxidation of the metal objects, and rancidity means what? The oxidation of the oil and the fats which are present in our food items. Now, once we understand these concepts, we can solve this question number 18, 19 and 20. So what are the examples of the corrosion? This rusting of the iron, it is also example of the corrosion. Means the corrosion of the iron object, it is called okay, sorry, means the rusting of the iron objects. It is an example of the corrosion. The tarnishing of the copper objects. It is also example of the corrosion. And both are the damaging processes. Now, how can we prevent the rusting of iron? How can rusting of iron be prevented? So there are some methods which we can apply to prevent the rusting of the iron. One of the method is that we can paint the surface of the iron objects. So if we paint the iron objects, then what will happen? This paint will act as a barrier. This paint protect the iron to come in contact with the oxygen. As a result, it will prevent the oxidation of the iron objects. So first method is painting. So we can apply the paint and this paint will act like a protective barrier. Next, rusting of iron can also be prevented by the method of galvanization. So galvanization also, it is one of the technique where the iron objects the iron objects gets coated with a zinc layer. So zinc also one of the metal. So if we do the zinc coating on the iron object, then zinc being more reactive, it will react with the oxygen. So what will happen? If we do the zinc coating on the iron object, this process it is called galvanization. So in this case, how this galvanization protecting the rusting of the iron? See, so zinc is more reactive than the iron. So zinc first react with the oxygen and it will form a layer of zinc oxide. And this formation of the zinc layer protects the iron objects from getting oxidized. Then we can convert the iron objects into its alloys. Alloys we know na, alloys means the mixture of the metal with metals or sometimes with metal with non-metals. For example, the steel. All of us we are using the steel utensils. So steel utensils also, if we convert the iron objects into its alloys, so alloys are very resistant to corrosion. They are not easily getting corroded. They prevent the oxidation of the iron. So in this way, the rusting of iron can be prevented. Now, how can we prevent the food items from getting rancid? So one of the method already I told no, we can keep the food items in a or we can mix some antioxidants with the food items. For example, nitrogen, it acts as an antioxidant. It prevents the food items from getting oxidized. Then the second method is that we can keep the food items in an airtight container. So if we keep the food items in an airtight container, then air will not able to enter or air will not come in contact with the food items. As a result, our food items we will get fresh. Then we can keep the food items in a refrigerator. So if we keep in a food items in a refrigerator, that also slow down the process of rancidity. So these are the two processes. Once we know these processes, then easily we can solve the question number 18, 19 and 20. And these are so small topic, but it is very important from our exam point of view. So corrosion means what? Corrosion means the oxidation of the, or we can say the eating away of the metal objects by the action of air, moisture or the chemicals. It is called corrosion. So what are the effects of corrosion on different metals? So iron objects gets covered with a layer of brown color. It is also effect of one of the corrosion. Then the copper objects gets coated with a layer of green color. Then the silver objects gets coated with a layer of black color. An example of the corrosion, the best example is the rusting of iron. How can rusting of iron be prevented? First, we can apply the paint on the surface of the iron objects. Second, by the process of galvanization. So what is galvanization? The process of coating the iron objects with zinc metal. It is called galvanization. How the galvanization protects the iron objects? Zinc being more reactive, it will react with the oxygen and it will form a protective layer of zinc oxide. Then we can convert the iron objects into its alloys. So alloys also, they are very resistant to corrosion. Now what is rancidity? Rancidity means the oxidation of the oil and the fats which are present in the food items, resulting the change of the smell and the taste of the food items. It is called rancidity. How the rancidity can be prevented? First one, we can keep the food items in a airtight containers. The second one, we can add some antioxidant such as nitrogen or some inert gases also we can add, which will protect our food items from getting oxidized. Okay, so just now I have discussed the process of corrosion and the rancidity. So this question it is related to the rusting of iron. So the question is, why do we apply paint on iron articles? So just now I have discussed now. So this paint, it acts as a protective layer. Generally what happens, if we leave the iron object, then iron object comes in contact with the moisture or the air, and it forms a layer of ferrous oxide, and ferrous oxide, it means it is the rust. So to prevent the iron object from getting oxidized, we apply the paint on iron articles. So what we can write, when iron comes in contact with air or moisture, it forms a layer of ferrous oxide called rust. Therefore, to prevent the iron objects from getting oxidized, we apply paint on the surface of iron articles. Generally, to prevent this oxidation, we apply over the surface of the iron articles paint. Okay, now the next question is, oil and fat containing food items are flushed with nitrogen. Why? So this question also already I have discussed now. This nitrogen acts as the antioxidant, and being inert, it prevents the food item from getting oxidized. So that is why the cheap manufacturers also uh, they flush their packets with nitrogen gas. Oil and fat containing food items are flushed with nitrogen gas because nitrogen acts as an antioxidant and prevents the food items from getting oxidized, and hence and hence protect the foods from getting rancid. This is the last question from our NCERT exercise. Uh, Question number 20. Explain the following terms with one example each. Corrosion and the rancidity. Though already I have discussed the corrosion and rancidity. Now we have to explain these two terms with some examples. So see, corrosion means what? The eating away of or we can say the slow oxidation of metal objects by the action of air, water or chemicals is called corrosion. Or we can say the process of slow oxidation of metal objects by the action of air, water or moisture or chemicals is called corrosion. Now the effects of corrosion on different metals are: first one, iron gets coated with a brown layer, that is the rusting of iron. Next, copper gets coated with a green layer. Next, silver gets coated with a black layer. So these are the different effects of the corrosion on different metals. And one of the example of the corrosion is that rusting of iron. So what is rusting of iron? Means the oxidation of the iron objects by the action of air, moisture to form the ferrous oxide or the iron oxide. This process it is called rusting of iron. Next, rancidity. So we know this is the oxidation of the oil and the fats which is present in our food items. Rancidity means it is the process of oxidation of oil and fats present in the food items resulting in their taste and smell. So rancidity means what? The oxidation of the oil and the fats which are present in our food items, and whenever this oxidation of the oil and the fat takes place, it develops a bad taste and the bad smell. Now, prevention from rancidity. So, how can we prevent our food items from the rancidity? So, these are the measures we can take to prevent our food items from getting rancid. First one, by keeping the food items in a airtight containers. Next, by adding anti antioxidants such as nitrogen to prevent the oxidation of oil and fat molecules. So there are more techniques are there to prevent from rancidity. So these are the two major techniques which we can apply to prevent our food items from getting rancid. Now, example of rancidity is what? So what will be the example? So during summer, when we keep butter outside, it develops a bad taste and smell. So this is one of the example of rancidity. So this was the last question from our NCERT example. So with this question, we are ending or we are concluding our first chapter, that is chemical reactions and equations. Thank you for watching.